So when you're trying to find the period for something like this, I always prefer just to factor this out. So I rewrite it as the cosecant of 2 times x plus, and if I factor it out at 2, I have to multiply it by 1/2.
Did you want to put in there?
Right?
Okay.
And so that tells you this is your b, and remember your period is equal to 2 pi over b for sine, cosine, cosecant, and tangent graphs, which means the period equals pi.
Yeah.
And then also the reason I factor that out is because now you can see your horizontal shift better. Your horizontal shift is just sitting right in. It's the opposite of whatever's inside there. So this is your, what do they usually call it, C in your textbook?
Yeah.
This is your C would be negative pi over 6. So it's shifting
Why is it negative?
because you take the opposite of it, right? It's like
Yeah.
the transformations graphs.
So that's my interval.
No, so your interval, so the hardest part of this is really to find the interval. So your period is pi, which means your interval is 1/4 of that. Your interval is 1/4 of your pi, but then you have to shift it to the left, pi over 6. So if this is your line right here, this is what I always do. I always I go from 0 to pi, and then I cut it in half, whatever that is, and then cut that in half, and then add that. And then what I do is factor in, I'll do this in a different color, and then I factor in the horizontal shift. So I'm shifting everything negative pi over 6. So 0 becomes negative. I'm subtracting pi over 6 from everything. I just go ahead and do the math for that before I do anything else, before I even draw in my vertical asymptote, or my y-axis. So the least common denominator is going to be 12. So this is 3 over 12, and this is 2 over 12. So 3 over 12 minus 2 over 12 is 1 over 12. So that's positive pi over 12. So this is 3 pi over 6 minus 2 pi over 6 is pi over 3. Now what you could do once you find this is you can just add 1/4 each time if you want.
So it's
Either way, you can add 1/4 each time.
just pi over 12, 4 pi over 12. And then you just reduce that to that?
Yeah, so reduce. So you could have also just you could add pi over 4 to this. So that's 4 plus 3, so that's 7 pi over 12. And then add pi over 4 again. Pi over 4 plus 7 pi over 12
11 pi over 12.
is 10 pi over 12, which is 5 pi over 6.
Oh, yeah.
And to make sure you did it right, find the distance between here and here, and it should be pi.
And this.
So you could do it either way. You could find those interval values either way. But that's how I do that. And then once I do that, then I draw in now I know my line is going to be right here. My y-axis is going to be right here. So I don't draw the y-axis in until I do all my shifts, the period and the shifts.
And then you can just draw
And then do the rest of your stuff. So then you can clean up your graph a little bit. Okay, so the next step I do is I look for my vertical shifts then and my amplitude. So my vertical shifts, I'll do this in red. There's my A. A is -3, and it's a cosecant. So I'm really looking at a sine graph, right? And then I'm flipping it. And then I'm shifting it up 1. So this is my D. This is my vertical shift. So 1 is going to be, let's call this 1 right here. That's going to be my midline. If I go up 1, that'll be my midline. My amplitude is -3, so I'm going all the way down. 1, 2, 3. I'm going down to -2, and I'm going up to 4 because it's 3. So I actually even like to draw in. I like to draw in a couple lines here and here, And I'll show you why I like to do that. Because when I draw those lines in, and now when I'm drawing my graph, so it's the cosecant graph, which is, so I want to graph the sine graph, but it's a negative. So remember what sines do. So I actually draw in a grid like this on all my points, and now I know it goes here, here, and here, because it's the sine graph, right? And then it starts going down instead of going up since it's negative. So those are here and here. So your graph is going to look like this. But remember, that would be the sine graph. We're actually doing the cosecant graph. So the actual answer, which I'll do in black,
It's just
now these are going to be your vertical asymptotes wherever it goes through the center line. And then here's your point, it flips upside down, or it flips like that. Here's your other point, it flips down like that. And there's one full period of your graph. And now you can see clearly what this point is right here in case they want you to label a couple points. This is 7 pi over 12 comma 4. This isn't even a point on the graph, right? Because the black is the graph. So really you just need those. Those are the real main points that you want. And this point down here is pi over 12 comma negative 2. And your asymptotes, they might want you to label your asymptotes as well. So this is x equals negative pi over 4. Was that 4 or 6? No, negative pi over 6. This one is x equals pi over 3. I'm just looking down here. And this one is x equals 5 pi over 6 if they want you to label the vertical asymptotes.